Mounting Media on Trace Evidence, produced and narrated by Cassandra Cavazos. To begin, what is mounting media? The mounting media holds specimens in place between a cover slip and a glass slide. The analyst's choice of the right mounting media is a separate topic all on its own. However, before understanding the purpose of mounting medium, one must understand refraction and reflection of light in a microscope, refractive index, and relief. Refraction and reflection. The ability of a microscope to both magnify and resolve will first depend on refraction, which is the bending of light. Refraction occurs when light goes from a medium of one density or refractive index to one of another, or simply when light goes through a substance and bends. When refraction occurs, so does reflection. Reflection is when the light bounces off a surface. A common example is like how a mirror reflects. Refractive index, or Ri, is the ratio of the speed of light in a vacuum compared to the speed of light in another medium. If the refractive index of a grain, for example, is less than the refractive index of a mounting medium, then it is reflected and refracted. The light from a compound light microscope will allow a viewer to see the edges of the grain. If the refractive index of the grain is equal to the refractive index of the mounting media, then there is no reflection or refraction. The light is unaffected and the grain is seen as invisible under a microscope. Refractive index is the factor for relief. Relief is the magnitude to which a colorless, transparent specimen can be seen under a microscope when it is immersed in different mounting mediums. The higher the refractive index difference between mounting medium, the higher the relief will be, which can then give a better contrast of the specimen in view. Now, I will begin to discuss mounting mediums. First, I will explain the different kinds of medium. Dry mount is the simplest type of mount because the object is merely placed on the slide. Wet mount is when the specimen is placed in a drop of water or other liquid, and is held between the slide and the cover slip by surface tension. There are different types of dry and wet mount mediums. One such mounting is a temporary type of mounting media. An example of this is an oil with a known refractive index, such as the refractive indices of matching liquids from Cargyle oil. Permanent mount is another type of media, such as Canadian balsam, which is a natural resin with excellent optical properties and a refractive index near that of glass. The advantage of using Canadian balsam is that the slides of specimen can be stored for a long period of time. There are other modern mounting medium that may have similar storage ability, but Canadian balsam has been around longer and is usually an analyst's first choice. A disadvantage is that this mount requires toxic solvents when preparing the specimen. It is also not very cheap to obtain. Semi-permanent mount is another type that involves Cargyle melt mount, which is a waxy solid in room temperature. It can then liquefy under modest heat from a water bath or hot plate and will become solid again upon removal almost instantaneously. Other common mediums used are per-mount, which is a resin dissolved in toluene. Clear nail polish is also another media used for scale casting and sealing the cover slip down to the slide. The advantage of nail polish is that it's readily available and does not require toxic organic solvents to treat the specimens. One disadvantage of the nail polish is that it seems to shrink when making mounts of very thick specimens. Next is the understanding of which mounting media will work best for the various types of trace evidence. So, what can be described as trace evidence? Trace evidence is transferred in small amounts when there is contact between individuals and/or objects. Examples of trace evidence include hairs, fibers, glass, paint chips and smears, soil, and everything in between. So which mediums will fit best for the numerous types of trace evidence? Hair and fiber specimens should be mounted longitudinally in a mounting medium with a refractive index between 1.51 and 1.56. This includes a temporary mount in Cargyle refractive index oil. Permanent mount in either per-mount or melt-mount 1.539 media can be kept for many years. They are both very stable and chemically inert to a wide variety of materials. If mounting media is done properly, the materials or specimens do not change and will remain in place. These are best for collections of hairs, fibers, pigments, minerals, and other substances. Dry mounts allow for an examination of a specimen's surface structure, which includes scale patterns and other physical characteristics. For hair samples, scale casts are prepared by using both temporary and permanent casts. These include clear, quick-drying lacquer, nail polish, Polaroid black and white photographic coating solution, and melt mount 1.539 resin. A permanent scale cast can also be prepared on Renzel clear plastic microscope slides. Oil mounts, such as Cargyle refractive index oil, allow for a clear observation of specimens with different refractive indices, easy manipulation and separation of particles, and problem-free transfers from one mount to another. These are best for particles, glass, and paint chips. In the end, it is the analyst's decision to decide which mounting medium, whether liquid, solid, water-soluble, organic, dry, or wet, will be appropriate to ultimately give great contrast in comparing trace evidence specimens.